So still graphing quadratic equations. For example, y equals 6x squared minus 7x minus 5. We can use the axis of symmetry to find the vertex and then use the y-intercept equals -5 and plot our graph from there. Or another way is we could factor this first. So if I factored this, I would get, let's see, 6 times -5 is -30. And two numbers that multiply, let's see, 35 times, no, 10 times 3 will combine to give me the 7. One has to be negative, and in order to get a -7, it would be a -10. Now I'm going to divide back out by the 6. And now reduce. And my factored form for this would be y equals 3x minus 5 and 2x plus 1. If I set this equal to 0, remember, anytime we're graphing, we want to set that equal to 0 anyway. So when I set this equal to 0, then I can use the zero product property to find that x equals 5/3 and x equals -1/2. This tells me, and I talked about this a little bit the last time in the last lesson, these are the solutions. So the solutions to the equation are 5/3 and -1/2. If I were to plug these back into the original, I would find that I get a true statement. So I know that these are actually the solutions. But on the function, as I'm graphing, if I decide I want to graph this, what happens to my parabola is I know that I have x-intercepts at 5/3 and at -1/2. So my parabola is going to cross the x-axis at 5/3 and -1/2. Remember, parabolas turn around, so they're going to cross the x-axis at two places. Sometimes they'll cross the x-axis or touch it at only one, and sometimes they'll do something like this and never even reach the x-axis. Remember, with the discriminant, these are the three possibilities that we know for solutions to a quadratic equation. If the discriminant is undefined or is less than 0, then we know there's no solution, and that tells us that our graph is never going to reach or touch the x-axis. Or the discriminant will tell us that we have one solution, which means it's going to turn around and touch at exactly one spot. Or there are two solutions, which means it's going to cross over and turn around on the other side and come back over again. So important information for graphing. At this stage of the game, when we're talking about graphing in factored form, all we care about is where are the x-intercepts. Well, the first thing we care about is where are the x-intercepts. We still need a vertex because we know that this graph, since there are two solutions, it's going to either come up through the first solution and then turn around and come back down, or it's going to come down, cross over, turn around and come back up. We don't know what's happening here. So we need to find the vertex. As soon as we know where the vertex is, then we can finish graphing this. We're going to take advantage of the fact that all quadratic parabolas, or all parabolas, are totally, completely symmetrical around the vertex, right? So if I know that these 2 points, and I'm not going to work with these ugly fractions, I'm just going to show this to you visually, and then we'll work with some simpler examples in a second. But if I know that these 2 points live here on the x-axis, if I find the exact middle between those 2 points, then I know that the axis of symmetry is right exactly between these 2 points. Remember, every point on one arm has a reflected point on the other arm. And so if I find, for example, that the vertex is here, then easy enough, I can plot in that graph. And I'm just going to dot it in because I don't really know where this vertex is. So I don't want to give you the impression that I'm actually graphing right now. What I'm trying to do is, without getting it all muddy and other stuff, I'm trying to show you that the solutions, which we've been finding all along by factoring and using the zero product property, the solutions that we get are the exact places where our quadratic parabola crosses the x-axis. So let's look at some actual examples that I'm going to graph out the whole way. Since we already know how to factor, we're not going to start with standard form and then factor. We're just going to start with factored form. So here we have a quadratic equation that's already been factored into x, the linear factor x minus 3 and the linear factor x minus 7. If I chicken feed or use the zero product property, I get that x minus 3 equals 0. And so x equals 3. And in the other case, x minus 7 equals 0. And so x equals 7. So if I want to graph my solutions, because these are the solutions, right? The solutions of a quadratic equation are always the intercepts. And in fact, I call this factored form in the title, but this is really actually using intercept form. So factored form is the same thing as intercept form, and intercept form is the equation written in factored form. Okay, I've said that enough times. So let's plot our solutions. We have one at 3, and we have one at 7. And so now what we know is that there is a parabola that either comes down from up here and moves up, or it comes up and turns around and moves down. But in any case, since I have two solutions, I know that I have a parabola that crosses the x-axis twice, and I know that this is exactly where it crosses the x-axis. That's why we get the name intercept form. Intercept form talks about the place where the graph intercepts the x-axis. So I need to find the vertex, because once I have a vertex, then these can serve as my 2 points, one on the right arm and one on the left arm. But I need the vertex. Well, what can I do? Let's see. Well, I happen to know that the vertex is always exactly halfway between any 2 points that are on a horizontal line. So since these 2 points are exactly across from each other, the vertex has to be on the line or the axis of symmetry that's exactly halfway between the two. How do you find halfway between 2 points? You add them together and you divide them by 2. So 7 plus 3 is 10. Divided by 2, and so 10 divided by 2 is 5. Now in this case, you didn't actually need to use the formula, because I think you probably guessed on your own that the x-intercept or the axis of symmetry was the line x equals 5, because halfway between 3 and 7 would have to be 5. But in case you can't tell, sometimes you're going to deal with ugly numbers like this. How would I find exactly halfway between 5/3 and -1/2? I would add them together and divide by 2. And so that's always going to give us the axis of symmetry, to find that average place between those 2 points, or halfway between those 2 points. So now I need the vertex, to find the vertex, I'm going to use the axis of symmetry just like I did in standard form, and I'm going to plug it back into my equation. This time I have factored form, no big deal. I'm going to say x minus 3, x being 5 minus 3 times 5 minus 7. Well, what does that equal? 5 take away 3 is 2 times 5 take away 7 is -2. So 2 times -2 equals -4. So I know now that the vertex is the point 5, -4, and I know that my parabola faces upward, and so I can sketch it in. And I have everything I need to graph this parabola. I have found the vertex, that's one thing that I have to find, and I have found a point on each arm. It happens that the 2 points I found are also the intercepts, or the x-intercepts, or the solutions, but all I cared about was finding the vertex and 1 point on each arm to tell me where that parabola lives. Okay, so let's do one like this one that has a fraction in it. only because I know how much you love working with fractions. 2x plus 1 times 3x minus 2 equals 0. So this is a quadratic equation in factored form or intercept form, which means we're going to find the intercepts. So I'm going to make room, put a graph in here. So first, let's zero product property. 2x plus 1 equals 0, and 3x minus 2 equals 0. So let's find the x values that make that true. I'm going to subtract 1 and then divide by 2. So in this case, x equals negative 1/2. And on this side, I'm going to add 2 and then divide by 3. And so I get x equals 2/3. So I have an intercept or a solution at x equals 2/3 and at x equals negative 1/2. Now what am I going to do with that? I need to find the vertex. The vertex I know is exactly halfway between these 2 points. These 2 points aren't very nice to work with, but that's okay because I know that the axis of symmetry in this form can be found by splitting the difference between these 2 points, finding exactly halfway. I can kind of picture it and put it on the graph, but I have to know what the value is, otherwise I can't calculate the vertex. So I'm going to take the axis of symmetry, which is add the 2 points. So I have negative 1/2 plus 2/3, and I want to divide that by 2. So the first thing I have to do is get a common denominator in the numerator. So negative 3 plus 2 times 2 is 4 over 6, right? Common denominator here. And then when I multiply by the reciprocal, I get 1/2 here. So negative 3 plus 4 is 1 times 1 is 1, and 6 times 2 is 12. So at exactly 1/12, just this side of the x-axis of the, just this side of the y-axis is where my vertex is. X equals 1/12. So my picture isn't exactly perfect because 1/12 would actually be super duper close to the y-axis, but that's the really cool thing about graphing without graph paper and tick marks. If I label this 1/12, it just is 1/12. So now when I look for my vertex, which is going to be down here somewhere, I have to plug 1/12 into my function. I don't really want to. I know you don't want to. I certainly don't, but we don't really have a choice. Our y value is going to be 2 times 1/12 plus 1 times 3 times 1/12 minus 2. And it looks like it's not going to be such a big deal because look, 2 divided by 12 is just 6, or 1/6 plus 1 times 3 divided by 12 is 1/4 minus 2. Simple, find a common denominator. 1 plus 6, all I'm doing is multiplying this 1 by 6 over 6. 1 plus 6 over the denominator 6 times 1 minus 8, again, just multiplying 4 over 4, the second fraction. 1 minus 8 over 4. So 7 times 1 minus 8 is negative 7. That's 49, or negative 49, over 24. And then just for the sake of graphing, I'm going to figure out about what that is. That's about negative 2 and 1/24. So it's going to be just about here. So now I know what my vertex is, and I'm going to label it because you have to label it. My axis of symmetry is 1/12. And then my y ordinate for that, well, I don't want the mixed number, I want the improper fraction, negative 49/24. So I know those are ugly numbers and you don't really like when I use ugly numbers, but I think it's important that you just not always be given the prettiest possible picture when you're learning, because you get the impression that math should be always pretty numbers. Turns out these aren't pretty numbers, but look at the size or the work in the problem. It's really not any more work than when I got pretty numbers. It's exactly the same process. All I'm looking for is first the solutions or the x-intercepts, which are at -1/2 and 2/3 in this case, plot them, figure out where the middle is by taking the average distance between them, 2 points, add them together, divide by 2, it's just taking the average, no big deal, and then plugging that number into the original to get my value out, and that's my vertex. Now, something else to ask. Notice, in this case, I have everything I need to graph this graph. I have my vertex, I have a point on the right arm, and I have a point on the left arm. I'm really done. But what if I needed to know what the y-intercept is? Sometimes you do need to know that. And you might have gotten to use the intercept form of an equation to graph, but now that you see there is a y-intercept, you might need to go find it. Well, you have two choices when you do that. The first choice is to take the factored form, 2x plus 1 times 3x minus 2, and now I'm going to distribute. 2x times 3x equals 6x squared. 2x times -2 is -4x. 1 times 3x is plus 3x. And then 1 times -2 is -2. Let's simplify. 6x squared minus x minus 2. I've converted to standard form, and that's my y-intercept. So sometimes when I want the y-intercept, I can convert to standard form just by distributing. And so I know that my y-intercept is at -2. Another thing I can do, I've got 2 ways I can do this. The other one is to notice, if I were to write this as an ordered pair, this would be x equals 0, y equals -2. And this is super duper important because on the y-intercept, x always equals 0, right? No matter where I look at a point here on this y-intercept, if it were here, y would equal 2, but x equals 0. If it were here, y would equal 3, but x equals 0. If it were here, y would equal -5. I'm making those up, obviously, because I don't really know exactly where those are. But y would equal, say, -5, and x would equal 0. On the y-intercept, x always equals 0. So I can go back to the beginning, and I can use that. I can start up here, y equals 2x plus 1 and 3x minus 2. I can choose to let x equals 0. So I can choose x equals 0 to find out when x equals 0, what is y? When x equals 0, y is always the y-intercept. So let's plug in 0 for x. 2 times 0 plus 1 times 3 times 0 minus 2. Well, that's 0, 1. 0 plus 1 is 1, and 0 minus 2, minus 2. So that equals -2. So I could have found the y-intercept in either way. One, I can convert it to standard form and use c, and the other is I can plug in x for 0. I kind of like this method better. Doesn't really matter. They both work just fine, and they both took about the same amount of time. You choose. So let's do a quick recap. When we graph in intercept form, what that means is we have our quadratic function that has been converted. So intercept form means you factor it to get the factored form. Right? So the first step is to factor. If it's already given to you factored, you're done. But if you're not given a function factored and you're asked to graph it using factored form, then you're going to have to factor it. Once you have the factors, then you use the solutions to give you the intercepts right here, right? We took our solutions to give us the intercepts, and then we're going to use the axis of symmetry equation for this form, which is to find the average. You add the intercepts together and divide by 2, And whatever that is gives you the axis of symmetry. And then just like before, we're going to plug the axis of symmetry back into our function. So that would be the fourth step. And if you need to find the y-intercept, then you would have to use one or the other of these two methods. Let's do, I'm sorry, I thought I was going to be done, but I think it would be useful to find our y-intercept for this graph. If we want to find the y-intercept, let's start with our original. Let's take the y-intercept is going to be x minus 3 times x minus 7. I'm going to force x to equal 0 because that's going to tell me where this graph crosses the y-axis. So if x equals 0, then I have 0 minus 3, 0 minus 7, and that's just negative 3 times negative 7, which is a positive 21. So somewhere way up here at positive 21, my graph is going to cross the y-axis.